Hello everyone, this is Pradeepa from Biomedical Engineering final year. Now I am present here radiation measurement and detections. First, we know about the what is the radiations. Radiation is the energy propagations through the space or matter in the form of waves of particles to main categories non-ionizing and ionizing. Ionizing radiation has enough energy to remove electron from atoms creation ions. Natural source includes cosmic rays, radon gas, and radioactive materials in Earth crust. Artificial sources includes medical procedures, nuclear power plants, and industrial applications. Then classification of radiations. Alpha particles, beta particles, gamma rays and X-rays and neutrons. Then units of radiations measurements. That is the SI unit for radioactivity measure decay events per seconds. Then using the gray. Then Sievers, column and kilogram. Legacy units are using in the radiations measurement. Then gas filled radiation detectors. It's mainly using to the operating principles, ionization chambers, proportional counters, Geher-Muller tubes and applications. First we see about the operating principles, that is the radiations ionizes gas molecules creating ion pairs collected by electrodes. Ionization chambers, low voltage proportional to radiation used for dose measurement. Proportional counters, medium voltage, gas amplifications factor, energy discriminations. Geher-Muller tubes. This is mainly used to the high voltage, large amplifications, then detect single radiations event. Applications, survey meters, contaminations of monitoring, area monitoring, and personally dosimetry. This is the gas filled radiations detectors. Then scintillations radiation detectors, which is mainly used to operation principle, that is radiation excites scintillator atoms which emit visible light photons. Light collections, this is mainly used to photons convert to the electrical signal by photomultiplier tubes or photodiodes. Then scintillators materials, that is used in the liquid scintillators and plastic scintillators. The scintillator materials are two types. Then advantages, high detection efficiency, good energy resolution, fast response time. Then application, gamma spectroscopy, medical imaging, nuclear physics and homeland security. Medical imaging like PET and SPECT. Then we are using the semiconductor radiation detectors. Operating principle, radiation creates electron hole pairs in semiconductor material generating electrical signals. Then silicon detection, that have a low Z material excellent for charged particles and low energy X-rays. Germanium detectors, high Z materials, excellent energy resolution for gamma rays, requires cooling. Then using the cadmium zinc telluride, that's a used in the room temperature operations, high Z material, good energy resolutions. Then the semiconductor radiation detectors using the application is gamma spectroscopy, mainly in X-ray imaging, space mission, particles physics, and medical imaging. Then additional radiation detections methods, radioisotope therapy monitoring, common traces using the FDG. Then radiation detection in radiotherapy, that is the treatment planning, beam verifications, then in vivo dosimetry, image guidance and advanced techniques are using. Radiation detections in diagnostic messages, X-ray detections, computer tomography, mammography, fluoroscopy and dose monitoring, that is used in the quality measurement and assurance. Personal radiations monitoring device, that is a personal dosimeters, film batches, TLD or OSL batches, electronic personal dosimeter. Application is mainly used to the occupational monitoring and also the emergency response, medical staff, nuclear industry workers. Then portable radiation survey instruments, that is mainly Geher Muller counters, ionization chambers, scintillation survey meters, alpha survey meter. Then applications are used into the contamination surveys. Then radioisotope identification devices, gamma spectrography, detector types, library matching, advanced algorithm, and application is used into the nuclear security. Then radiation port portal monitoring. Then radiation portal monitoring system, large scale detection, detector arrays, advanced algorithm, integrations capability, and application is used into them. Border security, nuclear non-proliferation. Then fundamental principle of radiations protection, that is the justification, optimization is the using the ALARA principle, dose limitation, prevention of accident, and regulatory framework, that is ICRP recommendations. Then the three principle of radiation protection, that's mainly in a time, distance, shielding, material selection, and also the procedure planning. Radiation protection equipment, lead operants. Radiation protection equipment. Radiation protection equipment, lead aprons, lead glasses, thyroid shields, mobile shields, then radiation reducing gloves. Then radiation monitoring and surveillance, occupational monitoring, area monitoring, environmental monitoring, and record keeping program components. These are used in the radiation monitoring and surveillance. Then industrial uses of radiation detections. Then ensuring accuracy and reliability, calibration protocols, intercomparisons programs, performance testing, and uncertainty analysis and documentation. Regulatory framework for radiation, international standards, national regulations, licensing requirements, and compliance monitoring. Then key areas: medical exposure, occupational exposure, public exposure, emergency preparedness. Then emergency response to radiation incidents, that's we already known in the hospitals and the radiations department, radiotherapy department. Initially assessment, specialized equipment, protective measures, dose assessment, coordinations. Then the future of a radiation detector technology, this is mainly known about the miniaturization, because the CT MRI is a large size. This is not a portable to hospital. Smart integration, machine learning, novel materials, and emergency applications. Then key takeaways, that is the diverse detectors technology, blood application, safety paramount, broad applications, technological evaluations, future detections. Thank you.